Hello, OpenStack. It's nice to see you all. It's nice to be here. I'm going to talk about PaddyPower Betfair and our journey as a company, as a set of development teams and technology teams onto the OpenStack Cloud that we've built over the last 2 years. Right, first of all, a little bit about us. PaddyPower Betfair, formed a couple of years ago by the merger of two online gambling sportsbooks, effectively. PaddyPower also have a retail shopfront operation. Betfair also have the Betfair Exchange. The Betfair Exchange is a peer-to-peer betting marketplace with an API. Betfair Exchange operates here in Australia. PaddyPower doesn't. Strangely, the Betfair Exchange is not a Betfair operation here in Australia. It's owned by Crown. It's a B2B operation. In Australia, we also have Sportsbet, which is quite well known and have been very busy during the Melbourne Cup. And in the US, we have TVG and Draft, TVG being a television tote betting operation. And finally, we have Timeform, which is a statistics and horse racing, actually football as well, data source to inform your betting. Anything on the left of the screen as you look at it is on our OpenStack Cloud. Everything on the right is not currently. That's an organisational situation. A little bit about me. I started at Betfair in 2006 as a developer. I went on to be a development manager of the Exchange platform. And then I've spent the last 2 years as a cloud populator. So my job has been to help the transition of all the applications onto the cloud that my colleagues have built. And then recently, I've become head of delivery enablement, and that is the function that continues to look after the pipelines that deploy onto our cloud, but also maintains the cloud and the deployments of the cloud and the infrastructure itself. This slide was thrown together from memory about all the different technologies that we use to build the product that serves our customers, from the relational databases, the NoSQL data stores, the messaging technologies, the caching technologies, the different languages that we code in, finally to the different channels that we serve our product through. So there's mobile, there's web, and more importantly, the API. The API is just for the exchange. The sportsbooks don't tend to have an API. And our exchange API it's where our traffic is generated. It's high frequency, low latency trading. We have customers that will place thousands of bets a second. And these are financial transactions. These aren't page views. They're vital to get right. You can't let someone trade money that they don't have. It's important. And when it goes wrong terribly because you falsify an entire market for the entire marketplace. Betfair actually acts as a wholesale market for a number of bookmakers who are looking to take positions and then trade them off. So these are critical transactions, so they require a lot of checking and all the fulfillment that goes with them. As a developer, it's nice to work in a place like this, right? You get the right tools for the right job, you have what you need. As the person responsible for assisting in the deployment and supporting the infrastructure that supports all of this, it's a little bit terrifying. Can give you the creeps at times, but that's the space we operate in. So in 2015, we decided to build a private cloud, and we had a problem statement before we did that. And this is actually straight from our wiki. This was the problem statement that we had in 2015. The slide on the right comes from the fact that what we had was feature development teams and infrastructure teams, and they interacted via tickets. And I was working out in Porto with our DevOps team at the time, and in a slight moment of irony, they decided to set up their own ticketing system. There it is. It's not the most efficient way to work as an organization. Everything takes time, and you can see the problems that resulted. The context switch and the speed of response is not what the feature development teams need, which means it's not what the business needs. Right, I've got some slides now. I don't expect you to read them all. but they're effectively the metrics we were going to measure the success of our cloud with, and also things that we were originally not going to do 2 years ago. And all the items in green are things that we ended up doing over the 18 months that we built the cloud and started populating it. I'll come back to the metrics at the end. I think that what was out of scope and ended up needing to be done is quite key, and it was, I think, due to the flexibility of OpenStack that allowed us to pivot that quickly to support the business when it changed its mind and when it merged and decided it wanted entirely different things from the project we were building. Right, this is what I'm not going to talk about. This is the design of our OpenStack Cloud and all the various components. There's a number of talks at previous OpenStack summits. Technical architect here, Steve Armstrong, is here. You can Google our white paper if you look up PaddyPower Betfair i2 reference architecture. This will come up, and you can read about it there. We've even won awards for this. This is a bit more what I'm going to talk about, but I'm not going to go into detail about the PaaS side of things, but this is an overview of how our PaaS works and the different sets of tools that go into that moment from the feature team or the infrastructure team doing a commit to it actually reaching production. And this repeats through the different environments. So the teams will set up as many pre-production environments as they need in their testing stages, and it is a completely repeatable set of steps all the way through to the production environment. I mean, CI/CD wasn't new to PaddyPower Betfair when we launched our OpenStack Cloud. We had that loop, coding, testing, deploying, but we had some challenges. We had 2 data centers. One was production, one wasn't. In theory, if we had a DR incident in one data center, we could have manually redeployed everything to the other data center, but we had no comfort, no proof that that was going to work. The hardware infrastructures were different. The tools were subtly different across dev and production. And our infrastructure was essentially static, and it was just the VMs, the deployments onto the VMs of the code that changed and went through the CI/CD process. It's a very small change to a diagram, but actually it means a lot. The infrastructure is now deployed as part of that process. So everything is now fully automated from your networks to your virtual machines, your GSLB. Everything is part of the deployment. And this means that everything's repeatable. There's no differences between production and pre-prod that used to cause so much grief and outages and customer pain and surprises from the development teams. Infrastructure is code, which brings, and hopefully I'll get to do some examples of this later, but it brings, once you have it for a large majority of your estate, it brings a fair amount of comfort, flexibility, and reporting. You can easily grep or search in some other way the setup of your infrastructure. You can do discovery, you can do risk analysis, you can do all sorts of reporting on the back of that, very simply. Right, so we had a cloud, a private cloud. We had hundreds of applications that we needed to bring on board. And we thought about a number of different ways we could do this. We thought about applications that were co-located in terms of their load, their traffic. So we could have brought an application, its cache, and its downstream components across in a logical way to limit the latency. We could have brought similar applications across in sort of batches. Once we learned how to do a particular type of application, a MySQL database, a Cassandra, we could have done them and then moved on. We probably should have done the more complex applications first. Would have saved us a lot of last-minute panicking with deadlines. But this happened. There was a merger just after we just put our first applications live. And this led to a change in our focus and our requirements. The business made a decision, a perfectly sensible decision, that there was no point running two very similar businesses on reasonably similar tech stacks doing the same thing. We were going to combine them. The Betfair tech stack had the advantage of having the exchange, which allows you to leverage the wisdom of crowds. There's things you can do with an exchange that you can't do if you're taking the risk yourself. The Melbourne Cup's just been on. I hope people have watched it. But during those few minutes of pandemonium, the prices that you could get on horse racing will have fluctuated wildly on each horse. If you're a sportsbook operator, it's crazy to accept bets in racing on a horse race. If you're an exchange, it's the wisdom of the crowds. People take their own positions. The prices will mimic actually what's happening on the track quite effectively. And that allows Betfair to allow cash outs and other products on their sportsbook by simply shifting the risk to the exchange customers who are by definition willing to take it. PaddyPower had dual DC resiliency. They could move traffic using a tool that would slide traffic from one data center to the other at will. And so the decision was taken to move PaddyPower stack to Betfair, but on condition, because we didn't want to lessen the reliability and the resilience of the PaddyPower brand, on condition that Betfair could also have dual DC resiliency. And this was then beholden on our OpenStack Cloud to deliver this. It was something we were going to deliver as a byproduct, and it suddenly became our primary objective. So we were now critical in line to this post-merger activity that was going on. And all of the feature dev teams are also absolutely up against it to build a second copy of the stack, to add the features that each brand had to this joint one in a pretty aggressive timeline. So we were essentially asked to simply fit in around the feature dev team's timelines, which isn't optimal. You end up onboarding, moving an application to your cloud without its cache, and you have to reach back to your legacy infrastructure in order to communicate. And there were all sorts of challenges that came as part of that. There were some things we did right, though. These are our locations. We have tech teams, quite large ones, in all 4 locations. Inclusion Romania, we have, I think, upwards of 500 developers. In Porto, where we operate under the brand of Blip, hence my T-shirt. London and Dublin, and there are hundreds of developers, technicians in each. And what we did as a group was we made sure we had people who understood our cloud, understood the pipelines that we'd built in each. So they were very closely co-located to the teams that were actually developing features and that were moving their applications across. If you think back to that ticket slide, one thing we learned very quickly was if a feature team had a sprint in which to move their application to our cloud, if they had to wait 3 days for us to iron out a problem and then we went back to them, they'd already started doing something else. And it's perfectly natural. So the idea was to have people with them, work through the problem with them, and fix it there and then. It wasn't always possible. We had storage issues where we had to develop entire new features within our OpenStack Cloud, and there's presentations on this, I think, in Boston by Marius about how we handled stateful applications that we've done in the past. And those took a longer timeline, but actually they were the minority. I think that goes back to the point I was making about we should have done those first, but we didn't always have the chance. This also worked quite well. This is using OpenStack's tenants to actually map to compute pools. So one OpenStack tenant within our cloud actually ties into a set of hypervisors and a certain amount of compute. And each of our logical feature verticals managed their own compute. They were responsible for making sure they didn't waste it, making sure they asked for more in advance. And we have a series of dashboards. I can hopefully get time to get through them later. An example one of a Grafana dashboard that shows a team, their hypervisors, what they're using them for, which of the guests are using what CPU, etc. And each of these are, I guess it's leveraging Conway's law, right? You're mapping to how your organization works because they're the people that make the decisions. They're the people who are asked to do projects. They're the people who get the budget for the projects and ask to cost them up. So it's their call. If risk and trading, who are the people who'd run the algorithms for pricing, need to do a new project, they'll come to you and say, we need this much extra compute. And we made it their responsibility. Right, so some things that were problematic. This is a slide from Agile development, and the point of this slide is to say that if you start by building something very simple but that works and people can move around on it, you'll have happier customers throughout than if you make them wait till the very end of the process before they have something that's usable. This is pretty much what we did. When we finished our pilot, we had production workload working on our cloud. We had the Exchange mobile site and settled bets on the Exchange, customer-facing, full production traffic on them. So we were on our skateboard from day one. One of the problems with this, and when you talk about people about cloud adoption or any type of adoption, is they go, find the most engaged team, find the team with whom you have the strongest relationship, and work closely with them. And one of the costs of this is that each team, they have to learn to skateboard, they have to learn to cycle, they have to learn to ride a motorbike, and then they have to learn to drive a car. And the teams that were closest to us, I think, at the end of it, are probably those that despise me the most as a result of this journey. The teams at the end who just got in the car, they've had no problems. They've turned up, the pipelines are finished, they don't change very much, they're more reliable. The ones at the beginning have probably gone through a few more battles than they would have wanted to. Could we have done that differently? I don't know. My thoughts on this are pretty simple. Don't overplan. I think if we'd overplanned, the business changes so quickly, what we would have done would have been wrong, and it would have been a more expensive mistake. There's an analogy of extreme skiers. They don't plan every turn on the way down a mountain, but they know where the big obstacles are, and I think that's what you need to do. And you especially need to do it when you're building something that's built on infrastructure. That's our data center manager. We have a data center. We need to buy equipment. We need to go through a procurement process, not necessarily as long as CERNs, who were just here earlier talking to us, but it still takes time to order, rack, cable, the infrastructure. Even if your OpenStack deployment is then automated on top of that. It's a monthly thing. So you do have to plan. Don't overthink it. Plan as little as you can and be reactive. There were other problems, which I've described as the unicorns, and that is not a unicorn. This is a slide about how every feature dev team has they're rightfully very proud of their applications. They all think that their applications are in some way special, in some way fabulous, and in some way can't fit on the cloud for whatever reason. And we had loads of different reasons. Some valid, and I'm going to get to a slide later with the more complicated ones. But we had ones like we use WebSockets, we're mission critical. Someone told me that once. The whole cloud has to be mission critical. That we had the low latency concerns, a whole series of things. And for me, whose job it was to engage with these teams and to discuss their concerns, it felt like Groundhog Day, and that is a particularly ugly groundhog. But there were some valid ones, some valid unicorns. And I think today with the survey that we're having here in Australia, I had to have a rainbow somewhere in my slides. Databases. It was there at the beginning. We weren't going to do databases. Databases, in fact, I think I saw in this last set of slides, databases weren't virtualized. The Infomix databases on which our sportsbook works, and actually we have MySQL databases as well, we are now running them virtualized in our cloud across data centers with a failover mechanism. It wasn't simple. It took a lot of time working with DBAs who had never, I'm going to say had never done a Git submission, but probably had never done a Git submission. I haven't asked them all. Weren't familiar with that way of working. They also needed a slightly different spec of hypervisors to everybody else, and that broke one of our fundamental rules, which was that all the hypervisors were identical, because then if one failed, you could just move the workload to a different one. The Infomix database hypervisors are different, and it breaks one of the principles of our cloud, but we can live with that. They have their own tenant, and that isolates them from the others. We thought that the exchange, Betfairs Exchange, has moved from an Oracle-based polling system to a journaling architecture based on Kafka and the Google's Raft algorithm. And there were concerns that we were going to slow this down, that by having cross-DC implementations of this, we were going to either lose data or cause things to be so slow that they wouldn't hit the timelines that are needed. The exchange runs on a 100 millisecond bet matching cycle. Within those 100 milliseconds, there are thousands of bets at times, especially when bets are cancelled at the beginning of a horse race, your unmatched position disappears. There's a lot going on, and it's financially critical, but actually, we've just finished this, we've just put it live, it works. Multicast. I have a number of legacy applications on multicast, sometimes for caching, but also for communicating across many applications. This was a bit of a nightmare. We don't have the large use case running across DCs, and we only managed to do this successfully with help from our SDN provider, New Arch Networks, which allowed us to multicast across and back down to the VMs on a different layer. But that has been solved, so it is doable. A number of the applications actually took the opportunity to architect this out of their application stack, which they were always wanting to do anyway, which was a bonus. And lastly, we run a TSDB instance on Hadoop. It monitors the data points for the VMs, the hypervisors, anything you can expose. It has business metrics in it, and it is the primary tool in our incident resolution for probably 100 feature dev teams across the organization. It's very busy, it's a large amount of data, and we look to move this from the old bare metal onto our KVM virtualization layer on our OpenStack Cloud. The guys, our SRE team, have been testing this. They got up to 140,000 writes per second. However, when they applied reads to it, it started to misbehave. And there's no point writing data that you can't read. We haven't given up on this. This is very recent. They're going back and having another look at it. But for now, we have probably hit, possibly hit a level where virtualization won't work for us. But there's the Ironic project and bare metal deployments, which we'll move to if we need to. Right, security. There were concerns from security. I think any big new OpenStack implementation, in fact, any big new project has concerns about security. I think one guy during the keynote actually said OpenStack was weak on security, which I thought was a bit harsh. We overcame the initial concerns. Our OpenStack Cloud actually allows a lot more visibility and control to our security team than they had before. It's much more orchestratable. The information is in one place and can be accessed in one place. So for example, we run vulnerability scans on our operating system images before we deploy VMs to them, so that our security team actually have the output from this, and they can decide to block, to flag, to contact us when they want. We don't patch anything in situ. We have a mechanism by which the dev teams are asked to redeploy their applications every 30 days. And if there's a patch, it will be brought into that and go through the pipeline with everything else. So nothing is long-lived, and therefore there's no bulk patching of 300-day-old VMs that need correcting. Fewer scans now need to be run in production, and we have static code analysis continues to be run as a part of the pipelines like it was before. But our security team have moved to a much more proactive model now. Rather than running reports afterwards and flagging risks, they're involved in that set of the pipeline. They can, and what they've done recently is actually to add some linting checks to the YAML files, so effectively controlling what infrastructure can be put in place. They've done this at the SDN layer to stop wildcards in some of the ACLs. So that's empowering them to have that conversation directly with the feature dev teams, not actually need the infrastructure team's input at all. We don't need to be the police here. Security and feature dev teams can talk and have a reasoned conversation amongst themselves. They also have this risk calculator where they add all the different data points they have about the security of a certain release, and if a number is triggered, they can go and have a conversation. It's currently done asynchronously. I guess if they wanted to, they could make it blocking. I'm not sure how well that would go down. And those 30-day redeploys I discussed earlier, they ensure that the config that we have doesn't actually creep from what is really in production. There's always a risk of someone going onto a box in an emergency, and we have a break glass system where people can go onto a box and change stuff in production directly. It triggers a post-incident review and an emergency change and all those good things. But that lessens that risk of the thing that you're analyzing actually being different from what is in production. Sorry. Change management. I was going to call them a necessary evil. I think I just did. The point here is that the operations team and your change team and all those service management functions actually have a role in the organization, and it's important for them to have visibility of what's going on. And what we found as a byproduct towards the end of our deployment was that there's a whole load of very easily accessible and rich data here that we can just throw them, or they can actually mine themselves. I'll demonstrate some in a minute, but this is talking about change management specifically. Our pipelines, our deployment pipelines integrate with our change management tool, which is ServiceNow. And at every stage, if our change management team want to, they can just block all changes, and then no changes will go to production. And that is their job. They may wish to, during the Melbourne Cup, not want people deploying code into production. I can understand why. There are other times like Christmas Day when the last thing you want is someone making a deployment. But again, like with security, it puts the onus on them. They now have the power and the information to make that decision, and they don't need to rely on us or anyone else to have that discussion. They make the discussion, they deal directly with the teams that they are impacting. I think the original ask was often for us to stop the pipelines. We don't need to do that, they can do that. They can also do, like security, they can have a risk calculator built in that says, this application has a very bad track record of releasing on a Saturday, we shall stop them releasing on a Saturday, if that's what they want to do. And the same is true for operations, the 24-hour guys that sit there and monitor and pick up the phone and listen to customer support and Twitter. They can now look at exactly what's been going on from an infrastructure level, from a application deployment level, and see what's changed, what's going on, what might be that first triage moment where they need to know which team to call out. They do that now with more data than they had before. And these aren't things that we designed in at the beginning. They're things that, because everything is now standardized, everything is now logged, we can just run Splunk queries, integrations with Slack, just tells you this information. And I'm doing quite well for time. So I'm going to talk about the metrics that I whizzed past earlier, which is probably why I'm doing so well for time. These were the ones that we were originally asked, and having looked back at them, slightly nostalgic 2 years afterwards, I don't think we paid a great deal of attention to them, but here they are, so we're going to go through and see how we did. Time taken to create and provision a new VM. The original set mentioned a figure of 5 days, on average, between a feature development team raising a ticket to have a new virtual machine and it being delivered to them in production. When we look now, we have complaints from the feature dev teams that it takes them 7 minutes to deploy from development to production. And if you consider that that is building all their VMs, They're networking in 4 different environments and doing it, bleeding traffic across onto that new build and tearing down the old ones. I think 7 minutes isn't too bad. The time it takes to provision a single VM is probably about 30 seconds. It really depends. Windows take a little bit longer, but that's how it is. Availability of underlying infrastructure as a service. I couldn't find any numbers on this. We did have issues. I think if you're building a new infrastructure like we did, there's going to be some surprises. I think my least favorite one was when we had a limit, an unnecessary limit on the number of BGP routes on our network switches, which caused a problem, and it just didn't need to be there. It was just a default setting that had been left on. Nothing key to OpenStack, nothing key to anything really. It's just when you're making this amount of change, there's going to be the occasional collateral damage. Maximum VM age, hopefully I'll get that up in a second. There's a sensor report we have that monitors that. Active loads spread all across the 2 data centers. And yes, we are now running this 50-50, and active passive loads as well. The applications move from one data center to another. We've done a whole series of tests where we've mimicked the loss of a data center and moved traffic. This works. We can dial our traffic across. We now have two data centers that can run independently, and actually we've had the luxury of speccing them out to run individually, so we have 100% of the necessary compute in each data center. Slightly wasteful, but that's what we have. Number of machines virtualized, currently 100%. We need to sort out that TSDB Hadoop problem, and we'll keep going. We will, and we know that we will, hit some loads that will need bare metal. We have some of the core Exchange components not yet on our platform, but we have everything else. We have both the Betfair Sportsbook, the PaddyPower Sportsbook, all the gaming stuff, live, in production, serving traffic on an entirely virtualized estate. And what will be next will be containers. I think if you've gone to any other sessions, you're probably aware that that's what's coming next. Number of open critical vulnerabilities on the infrastructure estate. I'm not going to give you a slide on what our open vulnerabilities on our production estate are. Would probably not be well received. I did look at the metrics here, and we went through a bit of a blip here. Not necessarily on the critical ones, but the security teams have much more visibility, especially on the overlay of vulnerabilities. And so actually, in the first instance, it did appear that we were making things worse. But actually, we just had more known issues that previously had been unknown. And with more known issues, you can fix them. Whereas with unknown issues, it's much harder. And the last two, the speed of deployment. These aren't relevant anymore. When you have an entire pipeline that deploys in minutes and rebuilds your infrastructure and deploys your application and runs the test in minutes, no one is measuring those, although they are complaining that they take 7 minutes. I'm going to attempt to get some live data up for you now on some of the things I just spoke about. Right. So, that is not where I want to be. So here's one example. And that's quite scary that they're deploying at midnight back in the UK. But this was something our 24-hour operations team wanted. They wanted that visibility I spoke about earlier of production releases. And this is just an integration from our pipelines via Splunk, because it goes via the logs. But this gives them that quick visibility in Slack of exactly what we deployed when. And it looks like midnight people were deploying stuff. If we were in the same time zone, it would be nice. I was rather hoping we'd get live deployments as I spoke, but given the time difference, it's understandable that we don't. Likewise, drilling into Splunk, here's the type of metrics you can throw up reasonably quickly once you've got this type of information at your hands. This is application deployments, where they've failed, which steps are failing. You can actually drill into how long each step took, should you want to. So suddenly you've got all this quite rich data that you can query in minutes, to be honest. If you can write a Splunk query and you know where the logs are, this is all available to you. Let's have a look at our virtual machine longevity. Or let's not look at our virtual machine longevity. Okay, I can't log into that. Right, okay, here's the piece I was talking about at one stage about each team owning their own hypervisor compute requirements. So this is the Exchange Mobile team, and this is their view of their compute. So you have the hypervisors, they can drill into the guests on the hypervisors, they can see what the average CPU is running at, and it's running quite high, 50%. So this is the type of information you can give to an organizational unit, and they can then turn around and say, we need extra compute. And when they say that, we can look at this as well and say, no, you don't. Or, wow, yeah, you do, depending on the data. So we're actually now able to run alerts on this. You can run alerts on this type of information to say, look, someone hit 80%, they'll need a new hypervisor potentially in the near future. I think that's what I had. Yes. I've got a couple of minutes. Does anyone have any questions? We got a microphone somewhere? Just say it loudly and I'll repeat it.
You mentioned there was a hypervisor restriction with your Infomix environment. What can you share with us around that?
So I don't know exactly where they were contended. So essentially we have these HP boxes, and the Infomix databases needed bigger boxes. Steve, what were they restricted on?
Yes, so basically what we did was we dumped everything to disk with they flushed everything to disk in the buffer, and essentially they needed more IOPS to do that, so they needed more memory to do that, so the general spec for it wasn't high enough. That was the only reason.
So it's an IOPS-centric use case, you needed a more IOPS-specific hypervisor?
Yep.
We did say to them they could flush over a higher time period, but they wanted it within that period.
But it wasn't that the hypervisor needed to be a different specific kernel or a specific...
No.
Is that something that we've hit in the field as well, where for certain use cases, not only certify certain kernels,
So we're going to hit a problem with the virtualization when we move to doing our Oracle databases, because Oracle won't certify Oracle databases on KVM. So we'll hit some problems like that, but not down to the kernel level, at least not yet.
We did Tenant as well, so we used the new one. But that was just the box that
Yep, sorry about that.
Just interested, you were talking about using the SDN layer when you are.
Yep.
Are you running things like microsegmentation, security?
No, we're not. We've had conversations with security. Where are we with the what security and the tapping and stuff of Nuage?
yeah, because basically we tapped before, and then it's all VXLAN, so essentially they can't see the data. So what we're doing is they're investing in new tooling at the moment, and going into market. I won't want to say which one we're looking at just now, because we're going through an artifact process, but they're looking at putting in a tool that actually integrates with Nuage further.
So the answer is not yet, I guess, for those that couldn't hear. There's an RFI ongoing, and we'll be doing that soon.
Sorry, what about the inspection of the east-to-west traffic? What do you use to do that?
I don't know what I can say exactly about what our security practices are on that.
Do you use a command center tool, something that inspects your whole environment?
Not something that inspects the entire environment, no. But like I say, with the RFI that's ongoing is looking for something to do, to combine things. Yeah.
If you have a chat with us after.
Yeah. A little bit wary about what I can and can't say about exactly what we are and aren't tracking. Any questions that aren't relative to the security of our applications? In which case, thank you very much for your time.